Allow me to consider open the meeting of the Dissertation Council for the defense of Sakharov's dissertation for the degree of the candidate of Chemical Sciences in the scientific specialty 02/003 Organic Chemistry on the topic Catalytic annulation of cyclic enols with 2H azerines as a way to new ortho-condensed heterocycles. According to the order of St. Petersburg State University, Scientific Secretary Gnetov Alexander Valentinovich from the 24th of December 2020, me, Kuznetsov Mikhail Anatolievich, Doctor of Chemical Sciences, Professor of the Department of Organic Chemistry, St. Petersburg State University, was appointed the chairman of this Dissertation Council, and by the same order, the members of the Dissertation Council were approved. Let me introduce them. Bokach Nadezhda Arsenyevna, and in the remote interactive mode we have Darin Dmitry Viktorovich, Doctor of Chemical Sciences, Boyarsky, Vadim Pavlovich in the remote interactive mode. In Moscow we have got Galina Anatolievna Gaziyeva, leading researcher of the Laboratory of Nitrogen Compounds, the Institute of Organic Chemistry, the Russian Academy of Sciences. Can you see and hear us? And Koroleva Yelena Vadimovna, Doctor of Chemical Sciences, Chief Researcher of the Institute of Chemistry, National Academy of Sciences, Belarus. And she is a scholar of our faculty. I can't hear you well. Please, dear colleagues who are in Zoom, can you hear well? I can see you well, but I can't hear well Mikhail Anatolievich. Also, here with us is a scientific supervisor of our applicant, Mikhail Sergeyevich Novikov, Doctor of Chemical Sciences, and audio and video recording of our meeting is being provided, the simultaneous interpretation from Russian into English, and if it is necessary from English into Russian, is also being provided. And at this time, an email address is posted on the live broadcast of the meeting of the Dissertation Council, where during the meeting all listeners can express their opinions and send questions to the applicant online concerning his dissertation and the current scientific discussion of his speech. This question will be forwarded to me, and I will voice them during the discussion. Questions must be related to the applicant's presentation and the content of his dissertation, and the name, position, and place of work of the author of the question must be indicated. In accordance with the procedure for awarding the academic degrees of Candidate of Sciences, the meeting of the Dissertation Council is considered eligible if at least 2/3 of the approved membership of the Council takes part in its work. And our Dissertation Council consists of 6 people. All of them, 2 of them are present here, and 4 members are in the remote interactive mode. All members of the Dissertation Council and the applicants are provided with audio-visual contact. Thus, there is a quorum. The procedure of today's meeting of the Dissertation Council, with a total duration of approximately 2 hours, is the following. A brief report of the chairman on the documents submitted by the applicant for a scientific degree and their compliance with the established requirements. 5 minutes. approximately. A short presentation by the applicant for a scientific degree reflecting the main points of his research, approximately 15 minutes. Questions to the applicant, strictly according to his report, no more than 2 minutes per question. Answers of the applicant, no more than 15 minutes for all questions. Speeches of all members of the Dissertation Council in turns, with their assessment of the dissertation research, with a summary of their position, with questions and suggestions for the dissertation, about 10 minutes per speaker. The speech of the chairman with the review, about 10 minutes. Answers of the applicant for a scientific degree to questions and comments of the members of the Dissertation Councils, no more than 20 minutes. Open discussion. Speeches at the request of those present at the defense of the dissertation of persons, with a summary of their positions and specific questions and proposals strictly on the topic of the research, no more than 2 minutes for everyone. At the same time, all interested persons are requested to register in the registration form and completely introduce themselves before their performance. Then, presentation by the chairman of questions addressed to the applicant, which came in order to discuss his speech, and scientific discussion on the broadcast of the meeting of the Dissertation Council. Answers of the applicant, speech of the scientific supervisor of the applicant, and discussion of the results of the defense by the members of the Dissertation Council before the open vote, during which the sound of the broadcast is muted. About 5 minutes. Especially if such a discussion is necessary. Then, open roll call, counting of votes with the entry of the results into the minutes of the meeting. Making a decision on awarding or not awarding an academic degree. Concluding remarks of the applicant. Dear colleagues, are there any questions or objections to this agenda? And if there are no objections, let me turn to the realization of the meeting. Please switch off the sounds of your mobile phones. Let me get down to the meeting, to the explanation of the procedure of the meeting. According to the order for the defense from the 14th of December 2020, Sakharov Pavel Alexeyevich wrote his dissertation research on the basis of St. Petersburg State University. His scientific supervisor is Doctor of Chemistry Mikhail Sergeyevich Novikov. The number of publications of our applicant, which outline the main provisions of his research, is 6 works in high rating scientific journals from the list approved by the Ministry of Science. There are no publications in all these publications are indexed by scientometric databases of Web of Science and Scopus, and the results of the dissertations were outlined in tens of reports and at all Russian and international conferences, and thus all the documents conforms with the requirements and are stored at the application file of our candidate. Distinguished board members, before giving the floor to the applicant, do you have general questions to the applicant? And if there is a necessity to announce and consider the entire list of documents submitted by the applicant for the defense, no questions. Now, brief presentation of our candidate, Pavel A. The floor is yours. Good afternoon, dear colleagues. The topic of my dissertation is catalytic annulation of cyclic enols with 2H azerines as a way to new ortho-condensed heterocycles. Ortho-condensed systems, heterogenated pyrrole rings, are often found in natural compounds and synthetic preparations with various biological activities. This slide shows some biologically active substances of this type and combines these polycyclic skeletons, marked here in red by the same methods, the development of which is devoted to this work. This method is based on the catalytic annulation of cyclic enols by azerines. The reactions of azerines with carbonyl compounds have been known since 1977. In the overwhelming majority of cases, these occur with the cleavage of the CN double bond of azerine and the formation of a pyrrole ring. Our research group in 2013, using one example, showed that a copper-catalyzed reaction of annulation of the rholine ring with the formation of bicyclic polypropyrrole derivative 3AA is possible, and with the rupture of another azerine bond. The fact of the breaking of the single CN bond of azerines by nucleophiles at the time was extremely unexpected, and the applicability of this reaction is in the series of cyclic enols also remained not very clear. All this served as the impetus for this dissertation research, the main goal of which can be formulated as follows. Development of the general one-stage method for annulation of pyrroline formation of highly functional pyrrolone condensate systems based on the catalytic reaction of 2H azerines with cyclic enols. The work posed the tasks of synthesizing a wide range of cyclic enol substrates, optimizing the conditions for using methods with azerines, determining the limits of applicability of the methods, experimentally and theoretically investigating the mechanisms of new processes. To study the limits of the applicability of this method, a wide range of enol substrates was selected, which includes both 5- and 6-membered enols, including both carbon and heterocyclic series with 1 or 2 oxygen of nitrogen atom in the ring. In addition, they differed from each other by the cyclic cycle of the carbonyl group. We should also know the presence in the structure of some enols to the carbonyl group at the alpha elements of the carbon bonds. The presence of this fragment, as it turned out, strongly affects the stability of the resulting pyrroline containing heterocycles. The positive result of annulation of the pyrroline ring with toluresyline upon catalysis with copper acetylacetonate, we began our studies with these enol substrates. It was found that the N-heterocyclic carbene complex of copper 1 works even more efficiently here, and in 15 examples using 3-toluresyl, this reaction was effective for the synthesis of polypropyroles 3, the yields of which reach 97%. In general, C3 carboxymethyl substituted tetramic acids give higher product yields compared to aryl substituted ones. It should be noted that the reaction is quite sensitive to the substituent in the 5th position. The product yield drops to 62% when this position is replaced by a selected group of and to 0% with a phenyl group. The azerine structure also has a marked effect on the product yield. So, if from monosubstituted azerines, polypropyroles are obtained in yields from 70 to 96%, then when going to distributed azerines, the yield drops to 26-40%. On going to tri-substituted azerines, the yield decreases even more and amounts to only 7%. Interestingly, under the same conditions, para-methabenzyl substituted enols 1C and 1D add to the CN double bond of nitro-substituted azer 2I, and azerines 36 are formed instead of polypropirols. On the one hand, these results can be explained by the sufficient nuclear philicity of enols 1C, D. The other is the rather high electrophilicity of C3 atom of azerine 2I, and with a decrease in the nuclear philicity of enol, the introduction of the ester group at the C3 atom of the acetyl group to the nitrogen atom occurs with the formation of the expected annulation product. To clarify the reaction mechanism, additional experiments were carried out, namely reactions in this presence of hydroquinone as a known inhibitor of radical processes. It turned out that the reaction of toluazerine with aryl substituted tetramic acid is almost completely inhibited by hydroquinone, and in the case of methacarbonyl substituted acid, the yield of the annulation product is only slightly reduced, which indicated different mechanisms of these reactions. As a result, we have proposed the following mechanisms for this reaction. The copper complex 41 formed in the first stage from aryl substituted tetramic acid coordinates the azerine given complex 42. Opening the azerine ring at NC2 bond gives the radical complex 43. The results of the reaction in the previous slide indicate that the reaction with 3 metacarbonyl substituted tetramic acids most likely proceeds not through the radical path but through the nitrine complex 39. In addition to the enol fragment, tetramic acid in the ring system contain an oxo group, a heteroatom, and an sp3 hybrid carbon atom. The transition to other 5-membered enol analogues did not have strong effect on the course of annulation. So for the closest analogues of enol 1-tetronic acids containing an oxygen atom instead of nitrogen in the cycle, the yields of bicyclic products also reach 97%. For the annulation of tetronic acids by azerines in the presence of copper catalyst, a mechanism was proposed through the nitrine complex 58, since the addition of temper to the reaction mixture did not lead to significant decrease in product yield. Red diagram. It is not for this that this reaction can also proceed in the absence of a catalyst. However, with a very low yield of furapyrrole product, and the main product is salt 51. For this non-catalytic case, we propose the following annulation mechanism. First, azerine is protonated with tetronic acid to form a cation, which then undergoes two transformations. The main direction is ring opening into amine 53 and the formation of salt 51 in the end. Simultaneously, the addition of the enolate at the CN bond of the cation with the formation of azerodiene 54 is realized to a small extent. Its protonation and opening of the 3-membered ring under the action of the second enolate molecule leads to semi-aminal 55, the cyclization of which, possibly via the intermediate imine 56, eventually leads to the annulation product 50. The replacement of the methylene group in tetramic acid 1 by the carbon-carbon bond of the aromatic system, which converts it into 6-membered enol 9, does not affect the result of catalytic annulation with 3 arylazerines. It was shown on 16 examples that the yields of tricyclic products reach quantitative ones. replacement of nitrogen for oxygen in the structure of enol 9 also does not prevent the reaction with azerines, but changes its direction. An increase in the electrophilicity of the C2 atom of cyclic enols leads to the appearance of another competitive pathway for the cyclization of the copper intermediate, namely the attack of nitrogen of the C2 atom and the subsequent opening of the lactone ring with the formation of perols 73, and the replacements of the aryl group with the ester group with enol 9 also changes the course of the annulation reaction involving the exocyclic carbonyl group in the reaction, which ultimately leads to the formation of dihydrofuroquinolines in yields from 50 to 87%. And the resulting dihydrofuroquinolines can serve as excellent precursors for luminescent furoquinolines. The arrangement of the carbonyl group and the nitrogen atom leads to enol 11, the reaction of which with azerine begins in the usual way, but involves intramolecular transfer of the methacarbonyl group, giving the enaminated starting substrate, which is annulated in the usual way. The formation of peroline fused adduct 63 from 3 aryl substituted quinolinols 9 proceeds similarly to the annulation of 5-membered enols. Opening of the peroline ring leads to the formation of enolate 68. Further cyclization with the formation of intermediate compound 69 ultimately leads to carbamate 64. Cyclization intermediate 66 proceeding through the attack on the less electrophilic ester carbonyl and not on the ketone carbonyl group can be explained by the reversible nature of the process with the participation of the ketone group. And part of the work was devoted to the copper-catalyzed reactions of azerines with 6-membered enols containing a carbonyl group at alpha carbon atom to the enol fragment. Optimization of the conditions showed that here the most effective catalysis with copper-2 acetate and not in methanol but in dichloroenate. Thus, in the reactions of enol 15, depending on the temperature, different annulation products can be formed. At 60 degrees, the main product is the expected pyrochloromethanol 80. With stronger heating, isomerization occurs through the breaking of the CC bond at the junction of the rings at the formation of products 81. Replacing an oxygen atom with a carbonyl group does not significantly change the course of the reaction. The pyroleonation product can be obtained in moderate yields using an heterocyclic copper-1 complex as a catalyst, and in the presence of divalent copper, the isomerization product is mainly formed. On going to enol 17, the formation of isomerized cycloadduct also dominates. However, it is unstable due to the easy opening of the oxazoline ring with the formation of pyrrhydrodine 86. But this turned out to be rather an exception to the rule, since for aromatic enols for the benzofuran series, it is more preferable to add the azerine double bond at CN without opening the 3-membered ring and form azerodines 91. For example, benzofuran 18A reacts under the same conditions, giving the annulation product and azerodine in the ratio of 1 to 3. These reactions turned out to be very convenient methods for the synthesis of similar azerodyl substituted benzofuranones, since the possibility of carrying it out with high Riga and stereoselectivity was discovered. Optimization of conditions with testing a wide range of catalysts show that the best results are obtained using nickel hexafluoroacetylleonate and trisulfisine complex of gold, leading to the formation of azerines in high yields and different, and sometimes even with opposite diastereoselectivity, which is due to the different mechanism of their action. Nickel tends to form enolates with 1.3 decarbonyl compounds. Subsequent interaction with azerine leads to the formation of zeridines, usually with low diastereoselectivity. The compound of gold, on the other hand, forms a complex with azerine. The subsequent attack of the enol occurs from the opposite side of the triphophosphine bulky group, which leads to the aziridines with high diastereoselectivity. And enol 19 of the benzophilazine series reacts with 3 aryzylurines in the presence of the nickel and gives the pyrrolynation product 96 in good yields. The unusual structure of the product indicates that the reaction proceeds through the opening of azerine at the double CN bond through the intermediate formation of aziridine. Copper catalysis in this case gave completely unsatisfactory results. Hydroxindole nevertheless enters into copper-1 catalyzed annulation reaction through the opening of the azerine at the single bond, giving compound 100A, but in a very low yield. Nickel catalyzed annulation of this indole proceeds through the opening of the CN double bond and leads to pyrrole 99 in 41% yield. Thus, the aim of the work was achieved. Thank you for your attention. Is there anyone who would like to ask questions? And our board members in the remote interactive mode. Can you hear me? Tell me, please, did you consider tricarboxy metal substitute in tetramic acid as tricarbonyl system? I agree with your statements and mechanisms, but it seems to me the tricarboxy metal substitute is radically changes the quality of the reaction, and this is trication system. Possibly tetronic acids, if we consider them, they demonstrate different behavior, but we don't have any experimental data to explain the mechanism apart from the products which we take from the reaction, which are represented in this slide. And similarly, different reactions demonstrate radical conditions, absence of copper catalysis for 3 tetronic acids. They demonstrate the formation of such products. I agree with your statements and explanations, but I want to say that out of your experimental data, we can see that this substitute is a unique one. For the reaction, it helps the output. The simplest, you mean acyclic. It would be better to start with them. Tetrahexane 3-diene is also possible. Thank you. I'm satisfied with your answer. Any other questions? Are you satisfied with the answer? Елена Вадимовна? Yes, I'm satisfied with the answer. Any other questions, please? I can't see any more questions. Board members and all those who are present. Any other questions? There are a lot of compounds, heterosynthesize. I am interested in luminescentic ferrolinens. Did you have such an idea to use them? We did not consider them as ligands. These fluoroxenolenons, so we consider them as to use them as fluorescent marks. I have got a question. Slide 18. Different reactions depending on the catalyzer. On the upper arrow yields 35-23%. What do you get there? There is a complex mixture of products. Did you manage to identify anything from this complex mixture? No, there are no such products. Everything is difficult there. Thank you. Any other questions? Like in master's classes. Complete silence. It's a pity, of course. Our colleagues in the remote interactive mode are keeping silence. I have got one more question, but it is in my review. Compounds which you got, were they biologically researched? Yes, they now are in Taliati State University for testing, and they show brilliant results. One more question. Mikhail Anatolyevich, can I ask one more question? Pavel, you used tetron acid. Does it have historical background, or you decided to use the reaction without catalyzing with purpose? The reaction with the teotetronic acid was successful, and then you started again with tetronic acid and make the reaction in methanol under 100 degrees, salt with yield 82%. If you take logical research, it should be with the tetranic acid. We started our research with tetranic acids reaction, and then we turned to cyclic enols, and logically that the optimal conditions of the reactions could change with the transition, not radically, but they can change. And we started with optimized conditions, and it starts with the reaction without catalyzer. And in this reaction we obtained salt 51. Thank you. This was just your logic. And one question from me. Once I worked with a chemist synthetic, and he thought if a person has 95% of experiments unsuccessful, it is a qualified chemist. And you have got a lot of experiments, and how can you appreciate your results, whether they are successful or not? If we compare tested enols, my percentage rate is more optimistic, more than 50%. It's not always that we expect, but we obtained some successful result. And the second question, your aim was to use reactions of azerines with active enol connection. How would you appreciate as initial task? Is there a chance to obtain success? Could you please repeat the question? The research of enol reactions with azerines as a method of synthesis of condensed heterocycles. How would you appreciate the chances for success and the solution to this problem? At the very beginning, fortunately, we had experimental experience which proves that it is possible, particularly the example with tetranic acid, and we obtained some results, and we must try, and then we can say something. Any other questions? External reviews. Are there any external reviews? No external reviews. And are there any volunteers apart from scientific supervisor? And now I would like to give the floor. No, the procedure is different. His floor is at the end. Now the reviews of board members first. Please, board members. Nadezhda Arseniyevna, Bokach, the floor is yours. I would like to thank you for the opportunity to have the floor and to be the board member. The complete text is placed on the website of St. Petersburg State University. The work of Pavel Alexeyevich, research the reactions of azerines and the methods of peroline cycle. The reaction of azerines help to obtain different reactions, and it is very useful for medication the volume of the material is very concise and diverse. The work is of practical value. The author developed different methods of synthesis, and the questions, my questions. The first question: which of the studied reactions and their products, in your opinion, have the greatest practical value? The second question: many reactions were carried out at 100 degrees in solvents. In the experimental part, in the description of such synthesis, it is indicated heating in a hermetically sealed tube. Can you tell us about the synthesis conditions and equipment in more detail? On page 94, it is indicated that when changing the catalyst in the reaction schemes 119-120 from copper 1 to copper 2, more rearrangement product is formed. What could be the explanation? The work is completed at high professional level. The articles were published in high ratings journals, and the work is highly qualified scientific work. There are approaches to the creation of the range of ortho-condensed system as a result of catalytic reactions of azerines. The dissertation conforms with the requirements stated by the order from the 1st of September 2016, 1621/1, the procedure on awarding academic degrees at St. Petersburg State University, and our candidate deserves the degree of the candidate of chemical sciences, specialization 020003, organic chemistry. Point 11 of the order was not violated by the candidate. Thank you. The answer to the first question about practical scientific practical significance. The proposed method for the formation of perylene ring is of great practical importance, since it allows to obtain a wide range of polyfunctional heterocycles, which are often inaccessible by other methods. It is difficult to single out the most promising among all the products. Interestingly, for example, ferric vinyls 72, which have luminescent properties with quantum yields reaching 86%, which allows them to be used in fluorescent labels. Some of the other polycycles obtained may be biologically active, and moreover, we have some preliminary positive results of their tests, but it is too early to talk about this more specifically. The reactions that were carried out at temperatures above the boiling point of the solvent, such as 100 degrees Celsius in methanol or dichlorinane, we carried out in a thick glass test tube, and it is closed with a threaded cap with a Teflon seal, which holds an increased pressure. In fact, such a test tube is analogous to an autoclave. As for page 49, it is likely due to the fact that bivalent copper is more likely to coordinate with 1.3 dicarbonyl intermediate 85 than monovalent. And as Lewis acid stabilize its negative charge. That's why the yield is more at compound 85. Thank you. I am satisfied with the answer now. I would like to give the floor to our board members in the remote interactive mode. Galina Antonovna Gazieva, please have the floor. It's a great pleasure for me to participate in today's meeting. The work is very brilliant. It is devoted to the synthesis of new compounds and heterocyclic compounds. They are widespread in nature, and they are applied in medicine as medication, in photodynamic therapy, in photochemistry, analytical chemistry. They are used as optic electronics, and without doubt the work of our candidate devoted to the synthesis of new condensed derivatives of pyrroline is actual and practically significant. The work is huge, interesting, very well designed, and it is the quality of the material presented is at high level, and the method turned out to be very effective. There are interesting processes, regrouping, bond opening, exercise, and it seems to me that any chemist synthesist will find something useful for him. The work, in this work, there are a lot of nitrogen and containing elements, and the work is presented in journals, high-rating journals, and I appreciate this work and I was impressed by this research. Page 27. It is written there that there are no radical presented, and the similar question concerning the compounds with fluorescent properties. How can you suggest further using? But my remarks don't affect the overall positive impression from the research, and the dissertation conforms with the requirements for the dissertations both at St. Petersburg State University and at other universities, and Pavel Alexeyevich without doubt deserves the degree of the candidate of chemical sciences in specialization 02003. Organic chemistry point 11 was not violated. As for the scheme on page 26, there is a mistake. And the authors of the work partly argued the non-radical nature of this mechanism by the fact that when the reaction was carried out in the presence of one equivalent tempo as a radical trap, the product yield was reduced by only 22%. Azide alkenyl groups are often introduced into the structure of compounds with a high quantum yield, which allows them to be bound to other molecules by azide alkyne cycliaddition and thus be used as fluorescent labels or markers. Perhaps it would be interesting to try to introduce these functions into the most promising synthesized structures. And now I would like to give the floor to Elena Vadimovna Koroleva. Thank you very much for the floor given to me. In comparison to previous video conference defense, the technical level is much higher. It was very interesting for me. First of all, I was impressed by the huge volume of the objects which huge number of objects which were researched, and apart from all the questions and remarks, there are many other questions. I am surprised. It is a young man, Pavel Alexeyevich. I don't remember when he came to work to our department, but he studied a lot of publications, and everything is described in his dissertation that it is necessary. He used a systematic approach. All yields are compared. The analysis of the extent of substitution was conducted. We heard everything. The work is characterized by a high extent of novelty. A lot of new compounds were obtained, and all heterocycles have biological activity and other useful properties. And the experimental work can be characterized as a diverse research to H. azerines as a way to new ortho-condensed heterocycles. A new method of synthesis of pyrroline condensed compounds was offered, and high experimental level of work is highlighted. It is a great achievement and proves his high level, and it allows us to say that he deserves the scientific degree. Detailed structural analysis, the description and study of physical and chemical parameters, the publishing of the work in high-rating journals. And when I see it, I'm very pleased. But please don't write 5-membered, 6-membered enols. You skip the main word, cyclic. Do you understand this? You must use cyclic. The results which were obtained by our candidate in general lead to the availability to new compounds. The candidate conducted independent experimental work which proves high professional qualification of the author in the sphere of theoretical and organic chemistry, and about his experimental mastership in the sphere of modern organic synthesis. And on the basis of my analysis, I am sure that the work is actual, novel, and practically significant. It is a completed work and proves the high scientific qualification of the author. I don't have serious remarks. The dissertation of Sakharov Pavel Alexeyevich. The name of dissertation conforms with the main requirements stated by the order. The number of the order, procedure on awarding academic degrees in St. Petersburg State University, and Pavel Alexeyevich deserve the degree of the candidate of chemical sciences, specialization 020003. Organic chemistry, point 11, was not violated by our candidate. Thank you. If you don't have anything to add, I would like to give the floor to Boyarsky Vadim Pavlovich. No voice. We can't hear you. Sorry. Good afternoon, dear colleagues. Everything good has already been said. The work is actual. It is connected with the fact that the aim of the candidate was the development of several useful synthetic methods, and it was achieved. From my point of view, the main dignity of the author, the offer of convergent methods instead of divergent methods. It is useful for complex synthesis. Convergent schemes are more useful. And our candidate successfully studied it. And the object of the research and the actuality of the work without doubt. There are a lot of elements of scientific novelty, and from the practical point of view, it will be useful for chemists. The work is very concise, and candidate demonstrates the knowledge of synthetic experiments, the use of chemical methods of the analysis, and the work is logical, and it proves the reliability of obtained results. My first question, it is connected with literature review. At the end of the literature review, the author gives a summary, and one of the conclusions is the statement that the vinylnitrene complex in general tends to exhibit electrophilic properties. At the same time, many diagrams in the literature review depict the reactions of vinylnitrene complex with electrophilic centers, that is rather a nucleophile. What is the reason for this contradiction? The second question, it was mentioned in the work that the stereochemistry of some annulation products was established in addition to the X-ray diffraction method based on NMR data. Was this analysis done for all products? This was not mentioned in the work, and it seems to me that in a number of cases the same stereochemistry of the products is simply postulated, especially considering that some compounds were obtained in an amount of 3 or 5 milligrams, such as, for example, products 100A and 100B. And apart from that, it would be better to show the methods for the calculation in the experiment. For example, quantum chemical calculation, it seems to be that in the experimental part, in this case, it was worth giving the calculation method. And there are some drawbacks concerning the design of the work. They are listed. My remarks are listed in my review. But all these remarks are not of principal character, and they don't spoil the overall positive impression from the work. The dissertation is a completed research. All the results are very well published, 6 works at high-rating journals. 5 of them are in 5 famous journals, and the abstracts, scientific abstracts of the reports are also published. In conclusion, I can say that the dissertation of Pavel Alexeyevich Sakharov on the topic catalytic annulation of cyclic enols with 2H azurines as a way to new ortho-condensed heterocycles conforms with the requirements stated by the order procedure on awarding scientific degrees at St. Petersburg State University, and the candidate deserves the degree of the candidate of chemical sciences in specialization 020003. Organic chemistry, point 11, was not violated by our candidate. This is my review. That's all. Distinguished colleagues, thank you for your attention. As for almost all mechanisms in the literature review are just speculative assumptions of the authors of the articles. Basically, the nitrine complex involved in them exhibit electrophilic properties. Scheme 14 depicts the reaction with palladium and not with copper. These particles are probably not worth comparing. Scheme 39, it is difficult to judge the philicity of the nitrine complex since the mechanism presented there hardly raises serious doubts about its validity due to the repeated jump of the hydrogen atom in the intermediate structures for no apparent reason. Scheme 58, the nitrine complex exhibits just electrophilic properties. In the mechanism in Scheme 71, the authors were not likely mistaken, since it is difficult to imagine the generation of an aryl cation in the presence of monovalent copper. Then, specifically for compounds of 100A and 100B, the stereochemistry is indeed postulated as cis, since the 5.5 fused rings cannot have transjunction due to the high tension of these systems. In the rest of the work, X-ray structural analysis was carried out where there were doubts, but in most cases, for at least one representative of each series of substances, X-ray structural analysis was necessarily performed. Among 17 PCA, 9 of them were from the products of annulation, and all with a cis arrangement of substituents at the junction points of the rings. As quantum mechanical calculations, I fully agree with this remark. It is a drawback. Details of quantum chemical calculations on page 71 are given in the accompanying material of the published article. And there are misprints concerning the schemes in literature review. Are you satisfied with the answer of our candidate? Yes, I am. Yes, I am fully satisfied. The next floor is given to Darin Dmitry Viktorovich. Thank you. Distinguished chairman, distinguished board members, all those who are present. It is obviously that the work of Pavel Alexeyevich, his dissertation, is completed at high level and designed duly. The volume of the experimental work is impressive, and diverse chemical behavior can be attributed to the objects of the research. The use of nitrogenous heterocycles. The review is very successful. It prepares the reader, it deepens him to this unique azurine chemical nature, and the fact that substrates of enol types, more than 100 compounds were synthesized by our author. We should highlight that these are not one-typed molecules. Here the author yields substrates with a fantasy. They are very diverse according to their structure, and this diversity of compounds, basic compounds substituted azurines, allowed the author to obtain the logic of the reactions depending on the nature of the structural fragments and strict structural limitations for each studied conversion. And the author investigates the issue in detail. he tries to state the limits of applicability and the specific approach for the use of the optimal conditions for each reaction. And the derivation from the main course of the research is presented. Azerines were tested and they lead to the development of effective methods of modification and obtaining of interesting heterocyclic structures. The use of quantum chemical calculations to prove mechanisms, and as well as the measurement of photophysical characteristics for some compounds having luminescent compounds is of high value, and the results of the research broaden the limits of applicability of azerines in tetracyclic compounds, and the significance and high evaluation is proved by publications. 6 articles, 2 of them are in Journal Organic Letters, one in Journal of Organic Chemistry, and 1 article in Journal Synthesis and Catalysis. The work is easy for reading. There are no misprints, inaccuracies, but let me voice some questions concerning the text of the dissertation. The first question: in the literature review, the author repeatedly noted cases when the use of vinylazide, the precursor of the corresponding azerine, in the reaction instead of azerine itself, favorably affect the yield of the target compounds. Could, in the author's opinion, this approach be more effective in some of the studied reactions? Then, the question: it is impossible to study everything. The author's opinion on the possibility of using such synthetically available substrates as 2 substituted cyclic SN1,3 diones and analogous cyclic diketones in the annulation reaction with azerines is interesting. Then, how can the formation of spirocyclic products of type 34, scheme 85, be explained only in the case of tetramic acids with N-azalyl substituents? And it looks unusual that structurally very similar compounds, 78 and 80, exist in different tautomeric forms, imine and enamine, respectively. How can it be? With what can it be connected? To sum up, the dissertation of Sakharov Pavel Alexeyevich on the topic catalytic annulation of cyclic enols with 2H azerines as a way to new ortho-condensed heterocycles conforms with the main requirements for dissertations, and our candidate deserves the degree of the candidate of chemical sciences in specialization 020003 organic chemistry. Thank you. As for vinylazides, in some cases this is indeed a good alternative to azerine technique. However, vinylazides are more difficult to store at minus 30 degrees centigrade. It is unsafe to work with them in large quantities, especially in closed containers. In addition, the yields of many reactions already reach 87%. And they don't require the heating. Question 2. Cyclohexane 1.3 diones. Unfortunately, due to the limited time with such substrates, the reaction was not carried out. However, the paper presents a carbocyclic enol 6 So the chance of a successful reaction is non-zero. As for spirocyclic products, the formation of spirocyclic regioisomers is observed in the presence of an N substituent at beta carbon atom of enol. Perhaps this is due to a decrease in the nuclear philicity of the carbon atom due to the negative inductive effect of nitrogen, as a result of which hydroxyl oxygen begins to compete in nuclear philicity with carbon. As for compounds 78 and 80, this is a very difficult question, and today we don't have a sufficiently reasonable and well-reasoned answer to it. Possibly the replacement of nitrogen by oxygen in the enol substrate cycle leads to an inversion of the relative stability of the imine and enamine forms of the products. That's all. Thank you. Are you satisfied with the answer? Yes, I am completely satisfied. Thank you. And the last review, my review. If there are no questions, please allow me to voice my... It was difficult for me to, both difficult and easy for me to write this review because the work is very diverse. It starts with a literary review where on 49 pages or more or so our author outlines the topic. It is based on 80 works. And the information field is very dense and informative. The works of last 5 or 7 years were used in this study, and as for literature review, the results obtained on the basis of them, and there are a lot of references to literary sources. Unfortunately, in literature review, because of its minimum volume, a lot of things were not discussed. There are no place for comments. And the description of literature data, then comes the outlines of your own data. I did not like the fact that it would be better to start with a description of what you want. There was only one formulation, that the development of new one-stage method of synthesis of annulation of cycle with the formation of ortho-condensed systems. And where is the order, where is the logic, what are the substituents, and so on. I did not understand that. There was only transition from chapter to chapter, and why did you use these compounds in these chapters? I would like to see that. Then there are no misprints, but there are some questions, starting with the first paragraph. It is noted that in the reaction of tetramic acids with azurines, an essential role is played by the formation of not condensed pyrols, but oxidized dimers of tetramic acid are necessary in the plan of operation, but nowhere is it indicated what serves as an oxidizing agent here, and how could one hope to avoid this process? Either copper to salt, and there are a lot of diverse paragraphs in the dissertation, and a lot of questions may be asked concerning these paragraphs. Although the work was published in very serious journals, I know that there are lots of drawbacks in the experimental part in these journals, and knowing this fact, I decided to check the experimental part randomly. Element analysis, spectrums in some places, and so on. And to my pleasure, I did not find any mistake. It is a very rare thing in this case, and it proves that our candidate knows about such mistakes, and he did not make them. After this introduction, I would like to come to a conclusion. The conclusion is very simple. It is a festivity of chemistry when from first basic, simplest basic things according to rules, conventional program, a lot of new interesting results were obtained. All these results were mentioned by my colleagues in the reviews. Every conclusion could become the conclusion of a separate independent dissertation, and the qualification of the author is without doubt. The results, the explanation of the results is also without doubt. In the course of the research, new general approaches for the synthesis of more than 10 types of condensed nitrogen-containing compounds were obtained. 8 reports at all Russian and international conferences, and the dissertation of our candidate conforms with the main requirements for dissertations at St. Petersburg State University. And its candidate, Pavel A. Sakharov, deserves the degree of the candidate of chemical sciences in specialization 020003 organic chemistry. Point 11 of the order was not violated by the candidate. There was one question about endimers, and they are presented in the slides. They oxidize the acidic part, and it is possible to avoid the formation of dimer and the formation of dimers can be avoided either by using an enol that is not prone to oxidation, for example, with an ester group in 3 position, or using a sterically loaded catalyst, for example, as I have already mentioned, and more active monosubstituted azirynes. In most cases, we used sterically loaded catalyzer, but when dimer was formed, you had the reactions when dimer was formed. Yes, we could not avoid that, but we managed to suppress this process partly. Are there any questions, remarks? Or maybe someone would like to have the floor? If there are no questions, please let us give the floor to the scientific supervisor. Mikhail Sergeyevich, the floor is yours. Distinguished board members, first of all, I would like to express my gratitude to the board members for your efforts, for your support, for your hard work. And Elena Vadimovna, Galina Anatolievna, thank you very much. As for my attitude to this dissertation and Pavel Alexeyevich's work, I can express my emotion, my delight. My candidate, he is a very hard-working person. I have known him for a long time, and he has always worked hard, and the volume of the dissertation is very impressive. As you mentioned, dense and diverse dissertation. Apart from this work, Pavel Alexeyevich dealt with many other scientific projects. If I'm not mistaken, multi-component reactions with the participation of azerines and synthesis of derivative amino acids which contain monolithic fragments, and on all these directions there are a lot of publications in high-rating journals. To sum up, I want to say that here we have got a person who works hard, but he obtains scientific data, successful scientific data. We are glad that after his postgraduate studies, Sakharov works at our department. He is a qualified scientist and deserves the degree of the candidate of chemical sciences. Any other volunteers? The next question to the board members. Is it necessary to announce a break in order to discuss the results of today's defense? No. And now the results of the defense, your opinion. Concerning open roll call of the board members concerning the results of the defense. I'm starting with those who are present. I'm for this work conforms all the requirements for the candidate dissertations. I'm for. And then Galina Anatolievna, I'm for. Elena Vadimovna, I'm for, without doubt. Vadim Pavlovich, I haven't changed my opinion. The candidate deserves the degree of the candidate of chemical sciences. I'm for. Dmitry Viktorovich, I'm for the degree. And as for me, I'm 4, as you can see. Thus, out of 6 board members who participated in today's meeting, 6 voted for, no one abstained, and no one was against. The positive decision is accepted about awarding the degree to Sakharov, Specialization 020003, Organic Chemistry. Our congratulations. First of all, I would like to thank all the board members for the help, for the consideration of my dissertation, and that you found the time to study my dissertation and to come here today for the meeting. And I would like to thank my scientific supervisor, my family, friends, and colleagues for moral support. Thank you for the attention. Thank you. I think that's all. We award the academic degree of the candidate of chemical sciences in specialization 020003, organic chemistry, to Sakharov. Thank you very much, everyone. Our meeting is declared closed.